Hey everybody, it's Mr. N here, and this is a right triangle trig practice worksheet. I want you to do this first, and then you can come through and watch the video and check your answers. But try it on your own first, make sure you know how to do it. Okay, so pause it if you haven't done that, pause, do it, and then come back and watch the video. So for problem number 1, we are to solve for x and y. And on this problem, let's take a look at what we have. We have this right triangle, and remember what we had talked about, and we know that we have SOH. I'll write it up here again on the side. SOH. And when I look at this angle right there, I want to try to solve for x and y. This is not a special right triangle. This angle is 36 degrees. And if I wanted to solve for the x, I need something that relates the x and the 8. Because if I tried to relate the x and y, I'd have two variables. This would be tangent, that would relate the x and y, opposite over adjacent. Wouldn't be able to solve for it. So let's use one that relates the opposite to the hypotenuse, and that would be the sine. So I could say the sine of 36 equals the opposite, which is x, over the hypotenuse, which is 8. So I end up with 8. Now you can put this as a ratio. 8 times the sine of 36 equals x. So on your calculators, make sure you're in degrees because this is a degree. So x will end up being 8 times the sine of 36, which is 4.70, we'll say 2. Now, if just to make sure that you're getting this correct, the sine of 36 comes out to be 0.58778. All right? Now, to solve for y, you could use the Pythagorean theorem at this point because we have this side and we have this side, and a squared plus b squared would be c squared. But instead, I'm going to go ahead and do the cosine since we were practicing trig here. So I will say the cosine of 36 degrees equals the adjacent, which is y, over the hypotenuse, which is 8. And this is like putting this over 1. So 8 times the cosine of 36 is what y is. So 8 cosine 36 comes out to be y being 6.472. I told you guys to go to 4 places. You can go to 6.4721. Again, to remind you, go to four places if you're taking the ratio. But in this case, we're just solving for the side length. You could have gone to the 10th like it's set up here, but I'm going to be consistent and just go to 3 or 4 places. All right, let's take a look at number 2. For number 2, we have the same scenario. We have x and y degrees this time. I can use the Pythagorean theorem to solve for this side, which I will go ahead and do because I want you guys to get all the sides and angles. Just like on this angle right here, this would have just been the 90 minus the 36, which would be 54 right there. So over here we have the x and y. Let's just go ahead and solve for this side. So we'll call this a. A squared plus 4 squared equals 6 squared. So a squared will be 36 minus 16. So a squared will be the square root, well, we'll just say a will be the square root of 20, which is 4 times 5. So 2 root 5 is what a is. So we know this piece as being 2 root 5. Now let's go ahead and solve for the x and the y. If I start with the x, I want something that relates right here, the adjacent, right there, the hypotenuse. Adjacent hypotenuse, that would be cosine. So the cosine of x would be the adjacent, which is 4 over the hypotenuse, which is 6. So the cosine of x equals, we could set this up as a ratio, 4 divided by 6 would give me 0.6 repeating. Actually, let's just keep it like this so I could put it in my calculators as 4 over 6, since it's a repeating decimal. So to solve this, remember we said we had to use the inverse cosine. We can't just divide by cosine. That's not a real operation that we could do. So we have to use the inverse of it. So we would say the inverse cosine of 4 over 6 is what x is going to be. That's how we're able to switch these out and swap them, by using the inverse cosine. Now, that's just a button on our calculator. So I will go ahead and do the inverse cosine of 4 divided by 6 on my calculator, and I will get x as being 48.118, we'll say 1897. We'll keep it to 4 places, and that's a degree. Now, to solve for the other one, you don't need to use trig functions. You can. You certainly can, but we can go ahead and we know that it's going to be 90 minus this answer. And we could do that, 90 minus this 48.18. And we'll get 41, this is for y now, we'll get 41.8103 degrees. All right, so let's move on to number 3. And on number 3, that angle is 50 degrees. Let's see what we could do with that. So here's my angle, 50 degrees. I can easily get this one. This one will be 40 degrees. Now I want to solve for x and y, so I want something that relates the opposite and the adjacent. If I did it that way to solve for x, which one relates the opposite? Tangent is opposite over adjacent. So TOA. So we'll say the tangent of 50 equals x over 5. And so that means 5 times the tangent of 50 is x. So x will end up being, let's do this on the calculator, 5 times the tangent of 50 degrees comes out to be 5.9588. Now, solving for y, you could again use the Pythagorean theorem, but I'm just going to go ahead this time, and I want to relate something that is the adjacent over the hypotenuse, so that I could show it to you with trig functions, and that is the cosine. So the cosine of 50 is the adjacent, which is 5, over the hypotenuse, which is y. If you put this as a ratio, as a fraction like that, you can cross multiply. You get y cosine 50 equals 5. So y will be 5 divided by the cosine of 50. And we do this on our calculators. 5 divided by the cosine of 50 comes out to be 7.7786. So we have x, we have y. Okay, moving on to number 4 now. So let's take a look at this. I've got my angle, 64 degrees right there. I could solve for the other one if I wanted to, if I'm filling out the whole triangle, finishing it out. So that would be 90 minus the 64, which is 26. And this piece is 10. There's x, there's y. So let's go ahead and start with this x. So what relates the adjacent right here and the opposite? Well, that would be tangent, because tangent's opposite over adjacent. So the tangent of 64 is the opposite 10 over the adjacent x. So cross multiplying again, you're going to end up, and solving for x, you'll get x equals, x times the tangent of 64 equals 10. So 10 divided by the tangent of 64 is what x will be. So 10 divided by tangent 64 comes out to be 4.8773. Again, at this point you can use Pythagorean theorem to solve for y, but I'm just going to go ahead and use trig functions again. So now I need something that relates this. Here's the angle 64, this opposite to the hypotenuse, and that would be the sine. So the sine of 64 equals the opposite from this angle to the hypotenuse. So that would be 10 over y. So y times the sine of 64 equals 10, so y equals 10 divided by the sine of 64. So 10 divided by sine of 64 comes out to be 11.1260. So I've got x, I've got y, we are all set. All right, moving on to the next problem, number 5. Let's take a look at what we have here. We've got this x right there, there's the y right there. I can do the Pythagorean theorem to solve for this real quick, and let's just go ahead and do that. So this, we'll call it C. C is going to end up being the square root of 12 squared plus the 4 squared. So C will end up being the square root of 160, and this is 16 times 10, so 4 root 10 is what C will be. And the only reason I'm doing that is this is good practice for square roots for you guys. All right, so now let's go ahead and solve. We could start with x. If I do x, this is the opposite, that is the adjacent. So I could say the tangent of x equals the opposite, which is 4, over the adjacent, which is 12. So the tangent of x is that, so that means the inverse tangent of 4 over 12 is what x is. Remember, to flip-flop these, you need to do the inverse operation. And that's how we isolate the x. So let's go ahead and do the inverse tangent of 4 over 12. And this comes out to be 18.4349 degrees for x. You could use a tangent again to solve for y. This time this would be the opposite and this would be the adjacent. Or in this case, let's just do it the easy way. 90 minus this answer. So 90 minus the 18.43, etc. That gives me what the value for y would be, and that would be 71.5651 degrees. All right. Continuing on. Let's see what we got next. This one, here is the 70 degrees. There's the x and there's the y. So I need something that relates these. This would be 20 if I wanted to solve it real quick. So let's solve for the x first. I need something that relates the opposite to the hypotenuse, and that would be the sine. So the sine of 70 is the opposite, which is 7.2 to the hypotenuse, which is x. Cross multiply and solve. So remember, it's going to be x times the sine of 70 equals 7.2, then divide by the sine of 70. So x will be 7.2 over the sine of 70. Okay, again, I put this over 1 and I cross multiplied and solved. So 7.2 divided by the sine of 70 comes out to be 7.6621. To solve for y, I can use the cosine, or I could do the Pythagorean theorem. So I'm just going to go ahead and do it with the cosine. The cosine of 70 this time would be adjacent, which is y, over the hypotenuse, which is x. But I already know what x is. So how about we do it a different way, though? We'll just use tangent this time. Instead of, you could plug this in and certainly do it that manner, but let's just go ahead and use tangent. If I said the tangent of 70, this would be 7.2 over y, because now I have the opposite, which I know, over the adjacent. I knew what x was. I could have certainly done it this way. I'm just showing you that you have options here. So y will end up being 7.2 divided by the tangent of 70. Again, if you can't see that, cross multiply y times the tangent of 70. Remember, all of this is one number by itself, equals 7.2, so you can divide that over. If this was an x here, you can't, just like we had here, you can't, right over here, you have to use the inverse to get the x by itself. So to get this by itself, it had to be inverse. This is attached. Just a reminder. Okay, so 7.2, let me get my calculator out again. 7.2 divided by the tangent of 70 comes out to be 2.6206. All right, let's move on to some of these word problems now. So for the first word problem, let's slide this up. It says a tree cast a shadow 21 meters long. So this is the shadow, so I'm assuming the sun's right there. This is the shadow, 21 meters long. The angle of elevation to the sun is 51 degrees. What is the height of the tree? This is sort of like what we were going to do with the clinometers that we didn't get to do because of the weather, but that's okay, and school cancellation, but that's okay. So let's work this out. I need to find this height. So here's the 51 degrees. I need something that relates the opposite to the adjacent, and that would be the tangent. So the tangent of 51 equals the opposite, which is h, over the adjacent, which is 21. So 21 times the tangent of 51 is h. 21 tangent 51 is going to be 25.9328. So h is 25.9328. All right, and that would be meters. Okay, moving on to the next question. This one is a helicopter. Let's take a look. A helicopter H is hovering over a landing pad P 100 meters from where you are standing. This is you. This is me. And the helicopter's angle of elevation with the ground is 12 degrees. What is the altitude? So again, we have to solve for the altitude here, which is the height. So we've got the situation where this is 12. I need the opposite. Opposite over the adjacent again. So it's the tangent. So the tangent is of 12 degrees. It's going to be h over 100. So 100 times the tangent of 12 is the altitude. So let's work this out. 100 on the calculator, tangent 12 comes out to be 21.2557 is what h is. 21.2557, and that's in meters again. All right. Looking good. Looking good. How are you guys doing? Hopefully you're getting all these right. Okay, moving on to the next one. Let's see what we have here. You are flying a kite. Again, here is me. Maybe I should put some hair on myself right there. Kind of a little smile. Okay, and I have to let it out 80 feet of string right there. The kite's angle of elevation with the ground is 40 degrees. If the string is stretched straight, how high is it? Well, this time I have to relate the opposite to the hypotenuse, and that would be the sine. So the sine of 40 is the opposite, which is h, over the hypotenuse, which is 80. So 80 times the sine of 40 is what h is. Let's work this out on the calculator. 80 times the sine of 40 comes out to be 51.4230. 51.4230, and that would be meters again. Real quick spot check, the sine of 40, just to make sure you're doing it right on your calculators. The sine of 40 should have come out to be 0.6428, just to make sure you're doing that right, 0.6428. Okay, here we go. Next problem. Let's change the pen color again. A 15-meter pole is leaning against the wall. So here's the pole. It's leaning against the wall. The foot of the pole is 10 meters from the wall. Find the angle the pole makes with the ground. So we need that angle right in there. Okay, let's see what we got. We have something that we need this angle. We have the adjacent. We have the hypotenuse. So that would be the cosine. So the cosine of x equals the adjacent 10 to the hypotenuse 15. Now remember, I can't just divide by cosine. That doesn't mean anything. I have to do the inverse, and that's what flip-flops these. That's how we solve and isolate x. So the inverse cosine of this ratio is x. Working this out on our calculators, the inverse cosine of 10 over 15 comes out to be 48.1897 degrees. So 48.1897 1897 degrees is what x is. And let's see what we got next. We have a few more problems here. A guy wire reaches the top of a 120 meter television transmitter. The wire makes a 63-degree angle with the ground. Find the length of the guy wire. Why is it called a guy wire? Why not just a wire? Why is it a guy wire? Anyway, okay, so let's take a look here. Here's 63 degrees. This is 120. I need something. Here's the angle that relates the opposite to the hypotenuse. So this time it's going to be sine. So the sine of 63 is the opposite, which is 120, over the hypotenuse, which is x. So x will be 120 divided by the sine of 63. Again, you could put this over 1, cross multiply, and solve. So 120 divided by the sine of 63 on our calculators comes out to be 134.6791 meters. That's what x is. All right. Moving along, an airplane climbs at an angle of 18 degrees with the ground. Find the ground distance the plane travels as it moves 2,500 meters through the air. So 2,500 meters through the air. We need to know what ground distance it covered. Okay, so this is our right angle right there. Here's our angle. We have something that relates the adjacent and the hypotenuse, which is cosine. The cosine of 18 is the adjacent over the hypotenuse, 2,500. So x will be 2,500 times the cosine of 18. So x will be 2,500 times the cosine of 18, which comes out to be 2377.6413. And yes, this should be less than that because the hypotenuse will always be bigger. So that's what this answer is, 2377.6413 meters. All right. And our last problem over here. Let's take a look at what we got. For this one, it says a lighthouse operator at a point P 25 meters above the sea level. So this is the sea level. We're 25 meters above. Sights a sailboat. So here would be the sailboat, S. Let's draw that sailboat. Let's go like this. I can be standing on the sailboat, doing math. Woohoo! At a point S, the angle of depression of the sighting is 10 degrees. So remember we talked about the angle of depression and the angle of elevation. So if this is 10 degrees here, this will also be 10 degrees because these are parallel. We're always going from the horizontal. How far is the boat from the base of the lighthouse? So we have to solve for this x. So here's my 10-degree angle, which matched the angle of depression. Angle of elevation and the angle of depression will always be the same if from the two vantage points. So this is 10 degrees, and I need something that relates the opposite to the adjacent. So we're going to go ahead and use the tangent. The tangent of 10 is the opposite, which is 25, over the adjacent x. So x will be 25 divided by the tangent of 10. So let's work this out. 25 divided by the tangent of 10 comes out to be 141.7820 degrees. So 141.7820 degrees is what this distance, or actually not degrees, sorry. It's not degrees, this is in meters because we've got a ground distance there. So this is meters. Be careful with that. Sorry, my mistake. All right, that was it. Hopefully you did very well on this worksheet. Again, rewind the video if you need help with anything. Try to put comments below, and maybe people and myself can help you out if you have any questions on any of these. Mr. N out.